Moving on to question 6, it just asks to construct truth tables of the following: P or P, P and inverse of P or inverse of P, and then P and P. So the first one, it's right here, P and P. So P, this is going to be, first one is true, second one is false. Again, P and P is going to be true. P or P is going to be true, and then 0 is going to be false. So for the next one, it's P and inverse of P. So P is going to be 1, 0. The inverse is going to be 0, 1. So both of them being true is going to be 0, 0. For C, P or um, inverse of P. So P is going to be 1, 0. Inverse of P, 0, 1. Either one being true, 1, 1. For the last one, they both have to be true. So 1, 0, 0, 0. That's basically it. For D, or for 7, it's a little bit more. You can see that the truth tables get a little bit long and get a little bit messy with it, but it's still the right answers for these. Um, for A, we have the inverse of P and Q. So again, just as a reminder, I'm going to only go through the initial P and Q in the beginning once, because we should know all this by now. And then I'll describe the additional propositions for the truth table as we go. So P is going to be true, true, false, false. Q is going to be true, false, true, false. So P and Q, where they're both true, is going to be true, false, 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 or 1, 0, 0, 0. And then when they are not true, this is going to be the opposite of our third column. So it's going to be 0 in the beginning, 1, 1, 1, or false, true, true, true. For B, it reads P and the inverse of Q. So the inverse of Q would read 0, 1, 0, 1, opposite of 1, 0, 1, 0. So P and the inverse of Q will only be true in the second row, where P is true and the inverse of Q is true. So 0, 1, 0, 0 is our truth table there. For C, it reads parentheses P and Q, and then also R. So for this one, it's going to be different. So P is going to be true for the first 4, and then false for the second 4. So 1, 1, 1, 1, and then 0, 0, 0, 0 here. Q is going to be true in alternating doubles. So true, true, false, false, true, true, false, false, and then R is alternating like Q was in the last one. So true, false, true, false, true, false, true, false. So here we're looking where P and Q are both true, which is only the first 2. And then the last one, we're looking where P and Q are true and R is true. So it's only going to be where they're all 1. As you can see, they're all the 1 in the first row. So 1, 0, 0, 0, 0, 0, 0, 0, 0 is our truth table. For D, I like to expand it a lot for these truth tables to make sure I don't get anything wrong. So for the first one, it's P, then Q, then R, and then I have P and Q, Q and R and P, and then I do the or operation of P and Q or Q and R, and then I add the last one of R and P. So P and Q are only true in the first 2. Q and R are only true when they're both true. So it's true here and true here, as you can see. R and P are only true when they're true together. So here's R, and then here's R and P, and then R and P right there. So P and Q or Q and R. So we're looking at these 2 rows of when they're true. So true, true, true. So it should be 3 trues. So 1, 1, 0, 0, 1, 0, 0, 0, true, true, false, false, true, false, 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 which is right. Now we're going to add this last one of R and P to the mix of this. So basically this is a combination of that, which is this entire expression right there. So we're looking for when they're both true. So true here, true here, true here, and true here. So there's 4 possible true, or there's going to be 4 instances where they're true. So 1, 1, 1, 0, 1, 0, 0, 0. For 8, it asks to determine the number of rows in the truth table of a proposition, calculating 4 variables, P, Q, R, and S. So if we go back, we can see that when there's 2 propositions, there are 4 rows. When there are 3 propositions, there's going to be double that. There's going to be 8. And then for F, oh sorry, I didn't go over F here. So F is equal to, or asks when P or Q or R or S is true. So P in the beginning, it's going to be equal for the first 8 instances because there's 16 rows. Q is going to be true for the first half of those instances, so 4 and 4. R is going to alternate like it did here for Q, so 2, 2, 2, 2, 2, so 1, 1, 0, 0, 1, 1, 0, 0, 1, 1, 0, 0, 1, 1, 0, 0, and then S is going to alternate every other one, so 1, 0, 1, 0, 1, 0, 1, 0, yada, 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 yada. So you're looking for when all of these are true, or you're looking for one of these are true. So I like to go row, just like the first column, so P, since it's asking for or, all of these are going to be true up to here, and then I go Q, so the next 4 are going to be true, and then I go R, the next 2 are going to be true, and then S, the next one's going to be true. And the last one, all are false, so the last one's false. So I was just saying, you can see that with the propositions, that the rows depend on the propositions. So 2 rows, or 2 propositions, 4 rows. 3 propositions, 8 rows. And this last one, 4 propositions, 16 rows. So you can see that it follows a certain pattern. 2 to the power of n, where n is equal to the number of propositions. So 2 to the nth power here will be where n is equal to 4. So 2 to the 4th is 16. 16 rows for the truth table, just like it is right here for PQ and RNS and PQ and RNS. I'm going to skip number 9 since I already explained number 9 for my assigned value. I'm going to go ahead and skip to number 10. So just given the prepositions generated by Q and R, which are equivalent to one another. So here's what I found. I went ahead and did every single proposition here. So just P, Q, and R. So we have 8 rows, 3 different propositions. I did the inverse. So I did the regular, and then I did the inverse, and then I started just going what pattern I feel comfortable in. So R to P, P to R, R and P, inverse of R or P, R or inverse of P, so G right there. And then I started grouping them all together. And then here's what I found. R to P, which is right here, this 7th column, is equal to inverse of R or P, which is right here. So we can see as they line up. 1, 1, 1, 1, 1, 1, 1, 1, 1, 0, 0, 1, 1, 0, 0, 1, 1. True, they're both biconditional. P to R is biconditional to R or inverse of P. So R inverse of P is right here, and then P to R is right there. So we can see 1 to 1, 0 to 0, 1 to 1, 0 to 0, 1 to 1, 1 to 1, 1 to 1, 1 to 1, 1 to 1. That's true. And the last set of equivalencies that I noticed were P or parentheses R or Q is biconditional to parentheses P or Q and R BQ. This is actually just the distribution rule that we have later. So here is P or RBQ, and then this was the last one. So 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 and 0 0. Just true. So 10. Is an implication equivalent to a converse? Verify your answer using a truth table. So I just did a simple truth table because that's what I asked. So here, implication is just going to be P to Q, and then converse is going to be the opposite of it. So here we have P to Q is not equal. And then our last one here, explain why a contradiction implies any proposition and any proposition implies a tautology. So I said that if the opposite of a truth statement is false, we can say the proposition is true. Which is true. We can say that basically a contradiction similar to how we use them in proofs, so we say that we use counter examples. like p to q is true, then if negative p to not negative q is going to be true, which is true. So that's how it basically explains the answer. Thank you guys for watching, and I hope you have a good day.